to the periodic table, excuse me. Background information, although we already know this, the periodic table is arranged by increasing number of protons. It's arranged by increasing number of protons. And what do we call this? The atomic number. Atomic number, okay? The rows in the periodic table, the rows, are called periods. And the columns in the periodic table are called groups or families. Elements in the same group of the periodic table have similar chemical properties. And they also form similar ions. Periodic table is grouped in lots of different ways. Okay, so like we said, number of protons. It's also grouped by families or groups, and also in periods. It's also grouped into metals and non-metals. And if I were to take if I were to start here boron and just kind of draw this staircase here like so. Draw a staircase down the periodic table like so. Everything on this left side of the staircase, over here, with the exception of hydrogen, hydrogen doesn't count, but everything else is a metal. And everything on the right side, including hydrogen, are non-metals. Okay, so hydrogen is also a non-metal. And so what does that mean, metals versus non-metals? Well, all metals have similar properties, and all non-metals have also we can say they have similar properties as well. Everything that's on the staircase, that's touching the staircase here with the exception of aluminum, is a metalloid, and we're going to get to that in a minute. So let's just look at some of the properties of metals. Metals are always good conductors. We should have said good conductors. Of both heat and electricity, or energy, right? Good conductors of heat and electricity, or simply energy. They are shiny, and we sometimes say that they're lustrous. Not all of them. It depends how you find them. Sometimes in nature they won't be as lustrous, but you can polish them, okay, and make them shiny and lustrous. They're also malleable. Malleable, which means that you can pound them into sheets. All metals have that quality, or most. Enough of them do to where we say that they're malleable. And they also lose electrons easily. Oh, I'm sorry, one more thing. They're ductile. Ductile, which means you can pull into wires. You can pull them into wires. Okay, you can form wires out of metal. And I'm running out of space here, but I'll go ahead and write it here. They lose electrons easily. They form positive ions. So these guys right here, especially in groups 1 and 2, with the exception of hydrogen, these guys lose electrons very, very easily. Okay? So we'll say lose electrons easily. They form positive ions. That's a positive sign. Form positive ions. Okay? Those are all the characteristics of metals. On the nonmetal side, well, the opposite of a conductor is an insulator. They're all good insulators. They tend to be dull as opposed to lustrous or shiny. They tend to be brittle as opposed to malleable and ductile. And they also gain electrons easily. Which means if they're gaining electrons easily, they tend to form negative ions versus positive ions. Okay? They tend to form negative ions. Now notice what we didn't say about metals. We didn't say, oh, they're all solids, right? We know hydrogen's a gas, but we didn't say all nonmetals are gases. That's because solid, liquid, and gas, if you recall, those are not chemical properties. Those are states. Okay, so and what we say is states at standard conditions. So at standard conditions usually means 0 degrees Celsius, but it can also mean room temperature. Anyway, so states at standard conditions. What are these? What are they found? What state are they found in at these standard conditions, these metals and non-metals? Well, at standard condition, none of these metals are gases. None of them are. Okay, there's one that's a liquid, and that's mercury. And the rest of them are solids. The rest. In standard, I'll leave that there so you can copy that. In standard conditions, nonmetals, the nonmetals that are gases are the noble gases and hydrogen. Oops, sorry, there's a few more. There's noble gases. And these guys are the noble gases right here. Okay, these are the noble gases in this group. And I'll label that in a second. Hydrogen, oxygen, fluorine, and I'm writing 2 here. That's H2O2, F2, nitrogen, N2, and chlorine, Cl2. And we'll address why there's a 2 after these later on. The nonmetal that tends to be a liquid at standard condition is bromine, Br2, and everything else are solids. Everything else. Okay, that includes carbon, sulfur, phosphorus, selenium, and iodine. I'm not going to write all those, but that's the rest of them. Okay? So let's go ahead and look at the categories of these different metals and nonmetals. We have the alkali metals, the alkaline earth, the transition, intertransition, other metals, and semi-metals. These are also called metalloids. The nonmetals, we have hydrogen, the noble gases, the halogens, and the other nonmetals. So let's start with the alkali metals. Alkali metals are group 1. This is group 1 right here. Okay, that's the alkali metals. And you can go ahead and label them. I'll do it down here. Over here. Give yourself some space because we're going to label a lot of these here. Okay. There's the alkali metals. These guys are the alkaline earth. This is group 2. By the way, alkali metals, I'll try to bring some sodium in for you. Very, very reactive. And we'll get into why that is later. Okay, these guys right here are the transition metals from 21 over to 30. Okay, transition metals. Okay, that's the transition metals. And let's see what else. Intertransition. Okay, that's these guys down here, although we don't really even deal with these too much, but I guess it's good to know that. Inner transition. Okay, these are the lanthanide and actinides, that's what we call them. And let's see, other metals is pretty much everything else, if I'm not mistaken. Let me just look on here on my notes. Yeah, other metals is everything else. So now the metalloids. Okay, metalloids are these guys right here. They're going to be, I'm going to go ahead and put a box around them. I really should have probably highlighted them, but that's okay. I'll highlight them. I think that's a better thing to do. Okay. Let me go ahead and pause this and I'll get a marker and highlight. Okay, and again, the reason I decided to highlight is because it's a good idea to know where this staircase is. Okay, it's right there. You want to kind of keep the staircase separate from these metalloids, okay? Alright, so again, these guys are called metalloids or semi-metals. Yeah, I'll say in yellow. Metalloids or semi-metals. Okay, these are a lot of times like silicone. We use them as superconductors. They're not good conductors unless you cool them down to a very low temperature. Okay, silicon especially, or silicone, however you want to say it. So there's that, and then the last thing is the nonmetals. This group right here, very important, group 7. They're called the halogens. That's the halogens, and this is group 7. Okay, group 7. The halogens. Okay. Group 7 is the halogens. These guys tend to pick up electrons. Let's see. And then the noble gases. Noble gases is group 8. Noble gases are non-reactive. They don't react. They're very stable. This is the noble gases. Okay, group 8, the noble gases. So again, halogens, very reactive. Noble gases don't react. There are 7 diatomic elements. They are all gases with the exception of bromine. And here they are. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Hey, check this out. Look, fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine. Hydrogen, nitrogen, oxygen. So look, if you go right here, and hydrogen. Okay, those are the 7 diatomic elements. So diatomic, what does that mean? Diatomic. Di means 2 atoms. Okay, 2 atoms, look. That's what diatomic means, and you need to know that. And I'll explain why they're diatomic later on. It's not necessary to know that right now, but it has to do with the number of valence electrons. Okay, I'm going to go ahead and make this video here. I'll do it separate. There's a little bit of chemistry humor. For those of you that enjoy chemistry humor, I'm going to make a separate video you can watch on your own. Okay, that's not Edpuzzle related. And this is optional. Obviously, I'm not going to test you on this. Everything else you will see it on the test. Okay, everything else will be on the test. So you need to familiarize yourself with this and memorize these different things that are on this page. Okay.